Alright, so how I found my extinction point, I used the light, I moved the films, polarized films around, and as you can see, I found it that way first. Can't see the flame. I sat it up. Whoop. One to one. Put this on top. And then you can see the film. So I rotated it until I found my extinction point. I used my protractor. Here's my ruler to measure the solution inside the beakers. Here are my calculations. I have my alkaline solution, my dextrose, and my fructose. I found my calculated specific rotation down here. I did each line. My dextrose came out to 36.84, and my fructose came out to a negative 19.3. I turned the page over and I did all of my math in the back. I calculated my optical purity, the racemic, as well as the plus and negative isomer in each amount. If you see over here, I took the 54 from the front, which gave me a way big number, my 364.67. So I did dextrose and fructose. They were my main two because they fit into the calculations. And I came out with dextrose. Has a 33.1% racemic mixture, and then it has an 83.4 of the positive isomer and a 16.5 of the negative isomer for the dextrose. So that's how I found my calculations. So this phenomena occurs that we can see the light is because we have sp carbon centrals on our chiral centers, and it's an optical rotation. So that's why we can get our different angles and this phenomena occurs. The various compounds alter the results is because they're made with different compounds. Dextrose and fructose are made with the same, but because of how they are actually aligned as the molecule, we get different results. And these molecules are all optically active because you get the different results. You see that they have observed observation. So you can still see through it at the 0 mark, so you have to literally physically move the second film to get a different type of angle, which gives us the observed rotation of how much I had to move the film to be able to have it completely blacked out. The concentration, purity, and identity of the substance affects the results. If the results are a little messed up, then I can't find what the optical purity is, which means I can't find the racemic mixture or calculate the amount of the isomer. So being able to actually find a good result is what makes it to where I can actually get a purity and identity of the substances. And then what must occur for this phenomenon to be observed? You have to saturate the substance. You can't just do this with a solid. It has to be a liquid form. So you have to have the saturation of all of the oxygen and hydrogen molecules inside to be able to see through and see if the light filters through. Hopefully that is what you were looking for. As you can see, I got decent results with the dextrose and fructose. My alkaline solution, I tried multiple times and just kept getting a huge percent error to where it wasn't lining up well at all. But that is Jennifer Jordan.